Okay. Thank you to join us for this webinar about heating and cooling planning at the local level. This webinar is organized by 3 EU-funded H2020 projects called HotMaps, PlanHeat, and Thermos, and it's organized in partnership with the Celsius initiative. Celsius is a collaboration hub for efficient, integrated heating and cooling solutions, supporting cities in their energy transition to carbon-neutral system. And Celsius gathers and shares technical, economic, social, and policy expertise. It connects members, exchange and foster innovation, which leads to solutions that accelerate sustainable development in Europe and across the world. So we are pleased to have 4 speakers today. So we have James, Ashley, Marcus, and Martin, and I will present them one by one along the webinar. But first I will start with a short introduction. So decarbonization of the heating and cooling sector is a key point to achieve a net zero emission economy. In fact, 50% of the energy demand in Europe is for heating and cooling, so it's a huge issue. And 81% of heating and cooling is still generated from fossil fuels. So it will require an important mobilization at local level to achieve ambitious decarbonization targets. And the thing is that there are many advantages to do a careful heating and cooling planning. So first advantage is to align your actions with the objectives of your sustainable energy and climate action plans. In fact, achieving ambitious emission reduction will require probably a greening of the heat supply, because right now the rate of building renovation is quite low, it's not enough, and both energy efficiency, so reduction of the energy consumption, and the greening of the heating and cooling will be required, both of them, if we want to achieve ambitious targets. Another point is that planning is the way to identify and tap local and renewable resources. Each city has a local context and can find a local and renewable solution. It could be waste energy recovery, it could be geothermal, it could be biomass. Right now, Energy Cities is part of an Interreg project called HeatNet Northwest Europe. And in this project, we are working with 6 cities which develop low temperature distribution heating and cooling networks. And each city has its own solution. For example, in the city of Dublin, we are going to recover heat from a data center. And in the city of Plymouth, we are going to supply the DHC network by a geothermal heat pump. Another point about the advantage of careful planning is to ensure consistency between energy infrastructure and urban development. I can give you the example of the city of Caen in France. They start to do an energy master plan, and they realize that they are building a new commercial area, but no one has studied the fact to use the DHC network to supply the heat in this new area. And so they did the study, and it was proved that in that case it was more cost effective to supply heat by the existing DHC network and to extend it.
Hi everyone, I'm James Wilson from Islington Council. I'm going to do the first presentation today. Hope you can hear me. So Islington is one of the 33 boroughs of London, and we're responsible for urban planning in the borough. So I'm just going to talk about the challenges for planning heating and cooling. I should also mention Islington, we're a member of the Thermos project. So just some background around our targets and objectives. So Islington had a target of reducing our carbon emissions by 40% between 2005 and 2020. And currently, according to the latest figures, we are at 36%, but the latest figures from 2016, so we appear to be on target. Going beyond that, the London Mayor has set a target of zero carbon by 2050, but in Islington, our local politicians want to try and get to zero carbon by 2030, which is a lot more ambitious.
Sie sind verbunden mit der Mailbox von
In terms of what we're doing locally, our own planning
Bitte sprechen Sie Ihre Nachricht nach dem Tonsignal.
requirement for developers to reduce their carbon emissions by 35% compared to the national building regulations, which set the current standards. And this is applied to all major developments, so that's developments of more than 10 houses or flats. We also have sort of wider objectives which are relevant, so we do a lot of work on fuel poverty, so Islington has quite a lot of poverty, and we're trying to help people save money by reducing their energy bills. And also air quality. London, of course, has very serious air quality issues, and so we're trying to reduce local emissions to help improve that. The current planning process, so almost a decade ago now, we did our first borough-wide decentralised energy strategy, and the idea of that was to try and look at where would be the best place in Islington for heat networks. So that was identifying areas of particularly large heat demand. So Islington is a very densely populated borough. Most of it is housing, but in some areas it's individual houses or terraces, and in some areas it's large blocks of flats. So the areas with lots of flats tend to be have bigger heat demand. So moving on a few years later, we did a decentralised energy master plan. So that followed on from the previous work and went into a lot more detail about the areas that we'd identified and what could potentially be done there. And then that led to some individual studies on certain areas. So Archway, which is an area in the north of Islington, so if you see the maps on the right-hand side of the screen, this sort of big red blob in the very north, that's the Archway area. So up there we have one of the biggest hospitals in the borough, and we also have 2 large housing estates, so that's got a lot of heat demand in quite a small area. We already have a small heat network, and we're looking at expanding that, and that's in the very south of the borough, so you can see the big red splodges in the south. And then the other 2, Caledonian Road and Highbury West, they're sort of in the middle of the borough, in that red bit going through the middle. So all of those we've looked at either starting a new heat network or expanding an existing heat network. In terms of what our challenges are, so one of the biggest issues is actually obtaining the heat load data. So the buildings that the council owns, so the housing estates and things like leisure centres, we know actual demand because we're responsible for buying the energy for those buildings. But for other public sectors, so hospitals, or especially for private sector buildings, whether it's housing or commercial, it can be very difficult to get the heat load data for them, which makes planning a network difficult. As I mentioned earlier, Islington is a very, very densely populated borough, so finding space to actually build a new energy centre, so whether it's a heat pump or CHP, can be problematic. The borough has, I think, the second least amount of green space of any district in the whole of the UK. Heat sources, choosing the appropriate one again is an issue. So I mentioned heat pumps and CHP. Again, Islington has a significant air quality issue. So going forward, we're considering whether CHP is going to be viable, especially with the GLA now looking at the impact of gas CHP on air quality in central London. Another challenge is the heavily congested subsurface. That basically means that under the roads in Islington there's a lot of stuff. It's a very old part of London, and you've got decades and decades worth of pipes, cables, you name it. And so some of the challenges we have when building our existing heat network was that when we were trenching down the streets to lay pipes, in some places there was one stretch where in about 20 metres there was more than 90 different cables or pipes crossing the road. Securing connection agreements from developers. So at the moment there's no legal requirement in the UK planning system for developers to connect to heat networks. So it has to be done as part of the individual planning application process, and there's a lot of disagreement about the sort of financial viability of connections, whether it's the developer wants to do the cheapest thing possible, which is usually just to install their own boiler or something, and then we have to try and make a business case for them connecting to the heat network. Unstable policy environment, so this is more related to things like the renewable heat incentive. So the UK has a policy to encourage heat pumps, and subsidies are paid to heat pump operators, but due to the sort of changes in direction, this has sometimes made it difficult to do long-term planning because you're not sure whether this subsidy is going to be available or at what value.
Sie haben die maximale Zeit zur Aufnahme Ihrer Nachricht erreicht. Wenn Sie so mit Ihrer Nachricht zufrieden sind, drücken Sie die Raute-Taste. Möchten Sie Ihre Nachricht erneut abhören, drücken Sie die 1. Um die Nachricht neu aufzunehmen, drücken Sie die Sterntaste. Um einen Fax mitzusenden, drücken Sie die 3.
So, finally, how can the Thermos tools help? So this is the project we're working on.
Wenn Sie so mit Ihrer Nachricht zufrieden sind, drücken Sie die Raute-Taste. Möchten Sie Ihre Nachricht erneut abhören, drücken Sie die 1. Um die Nachricht neu aufzunehmen, drücken Sie die Sterntaste. Um einen Fax mitzusenden, drücken Sie die 3.
Having a tool that allows us to do things like this very quickly and easily will be a huge help.
Wenn Sie so mit Ihrer Nachricht zufrieden sind, drücken Sie die Raute-Taste. Möchten Sie Ihre Nachricht erneut abhören, drücken Sie die 1. Um die Nachricht neu aufzunehmen, drücken Sie die Sterntaste. Um einen Fax mitzusenden, drücken Sie die 3. Vielen Dank. Ihre Nachricht wurde übermittelt. Auf Wiederhören.
Knowledge and experience of doing stuff, things like this. And then finally, best practice sharing. So as part of the Thermos project, we're working alongside 7 other cities around Europe, and also with other consultants and organisations involved with heat network planning. So it's helping us to learn what's happening elsewhere and hopefully pick up a few new tips. Okay, I hope that was all clear, and thank you very much.
So now Daniela is asking about, can you build up on how energy poverty is being addressed with correct planning? James, do you have any answer to?
So in terms of the planning, when the areas we're looking at heat networks, we've also tried to specifically identify certain areas with high levels of fuel poverty. So of those feasibility studies I mentioned, one of them, which was the Highbury West one, that's an area that has particularly high levels of fuel poverty because we have some very large concrete tower blocks there that have inadequate heating systems, and the residents are spending a high proportion of their income on their heating bills. So that's one of the reasons why we're choosing to focus work in that area. I think more generally, a lot of our work is trying to identify where the fuel poverty exists and then focus on general improvements. So if it's not heat network planning, it might be boiler improvements or insulation or any other kind of work that would reduce people's fuel bills.
Okay, thank you very much, James. I think now Marie-Anne is typing maybe another question. Okay, so there was some problem from Marie-Anne. Can you just very quickly say again what will be the heat source? It will be biomass, waste, or geothermal energy, James, in your project?
So in terms of the heat sources, I think the current networks we're looking at are usually gas CHP. The other ones we've been looking at are heat pumps using waste heat. So in central London there's lots of sources of waste heat. So one we're building at the moment is taking heat from the London Underground tunnels. We're also looking at data centres, electrical substations, water source heat pumps in canals. So that's the main focus. I don't think we've been looking at geothermal in London, and biomass is not really possible, both due to air quality restrictions and also transporting the biomass into central London, potentially problematic. Gas CHP, carbon neutral, that's a very good question. One of the things that we raised, we've been looking at the sort of the challenges and risks of going carbon neutral, and potentially it might need to involve offsetting, especially if we've got infrastructure, gas CHP infrastructure that's relatively new and wouldn't need to be replaced very soon. Then yeah, offsetting is probably the answer to that.
Okay, thank you very much, James. I think we will continue with the next presentation. So Marcus, can you share your screen, please? So Marcus Hummel works since more than 10 years as a researcher and consultant in the field of heating and cooling. His focus lies on the development of sound policies and transition pathways towards low-carbon energy systems. He is a senior researcher and managing director of Heating, a spin-off of the Energy Economics Group at the Technische Universität Wien. So Marcus, the floor is yours. Thank you very much.
Thank you very much, Julian. Just a short question. You can hear me, right?
Yes, we can hear you very well.
Okay, perfect. Yeah, so good afternoon, everybody. I will use the next 10 minutes to show to you the hot maps toolbox. So I will have a short presentation for you, and then I will also show you the toolbox directly. As you can see here, maybe as a first information for you, the project is a 4-year project, and we are now after 2.5 years of the project, so 1.5 years is still to go. What hot maps offers to you? First, I think important is hot maps is an online software, so it's a website you can join or you can use via the internet, and it supports planning processes of heating and cooling systems. And the second thing, it offers a starting data set. So we have developed a default data set related to demand and supply potentials for heating and cooling, of course, for all locations in Europe. You have also the opportunity to use individual data in the tool. So you have the default data, and you can also use individual data for your location. It also, the hot maps team also offers customizations of the software for your specific needs, and there will be training and support services. The status, as I said, we are after 2.5 years of the project. Starting with the development of the default data set and the toolbox, so we can distinguish between the two parts, the data and the toolbox. So the data set is finished, most layers are online, I will show to you later. Second, the toolbox in a first version, in a beta version, is available, and more calculation modules are going to come in the next releases. So the next release is planned for June this year, and then we have one in autumn, and we will have a final release next year. Then testing and demonstration, of course, the toolbox and the data set is tested and demonstrated. First, the default data. We tested the default data in around 20 locations EU-wide. And analyze the differences, the deviations between the default data set and local reference data. We are currently preparing a journal paper on that, so that's finished. Second, the calculation modules, they are developed. Most of them are developed in the first version. They are currently tested, and we also demonstrate them via using the calculation modules to derive strategy elements for 7 pilot areas around Europe. They are partners in the project. And third point, training and support activities. Of course, we will provide training on the use of the toolbox. We will have 5 training workshops across Europe. The trainings will start end of this year and will go to summer next year. So the first workshop is fixed. It will be in Bolzano in December this year. Second one will be in Brussels in February, and the others are still not fixed, but to be announced. here I provided for you several links. So you have here a link to the current version of the Toolbox, to the project website. We have started a wiki page with documentation of how to use the tool, a manual, and also method descriptions and so on. Also, all the source code and data is open source, so you can find it here. And if you have further questions, you can whether use the email that is provided here for the Hot Maps project, or you can directly get into contact with me. Yes, so that's that's the presentation. Now I would go into the Toolbox and show you a bit how it works. So here you can, for example, start, I think could be the most easy, start at the project website. You have here then a link to the software. So this is the website where you can get into the software. So here we are. You see it looks like Google Maps, let's say. So it's a map of entire Europe. And yes, so you have different scaling levels. So you have, for example, the country levels, NUTS 1, 2, 3. Then you have the LAO levels. So this is the local level. And you also have the hectare level that you can choose here. And then you have different layers. So these layers that you have here, that you see here, are the default data. So, for example, you have heat demand density for all locations around Europe. You can see here, for example, Paris and all bigger cities. You see heat demand. You have this for residential. You have here also the symbology, so you see what it means, the different colors. You get also information here. So here you have a link to the data for download in the GitLab. You can here also download them directly, whether the selection or the entire data set. What else do you have? You have gross floor area values, for example. It's also a density layer, so you can see that you have the gross floor density available. You have building volumes. You have data for industry, so you have, for example, industrial excess heat for various sites around Europe. You have the different subsectors, so you can see here which type of industry you have in the location. You also have the population densities. You have various renewable energy source potentials, wastewater treatment plants, for example. But you also have, for example, agricultural residues, or you have forest residue potentials. You have climate data, for example, heating degree days for all locations around Europe. And you also have electricity CO2 emissions for entire Europe. Now, click that, and you can, of course, go to a location. Let's say I show you Salzburg in Austria. So you can put that in here, and then you come here to Salzburg, and now you have the option, for example, you want to get an indicator for the city of Salzburg, so you can choose the regional barrier of the city and then say, okay, I want to see the heat demand, and I also want to see the gross floor area. I have chosen this region, so I can see then the total heat demand, at least as it is given in the default data. I can see also the gross floor area values, and I can also do that for self-selection, so I can also select parts of it, load the results, and see the indicators. And then I have also the option to calculate scenarios with different calculation modules. At the moment we have only 3 testing modules in the beta version, but as I said, this is going to come and to become more and more. Yes, so I won't show it now. I think my time is also over, so I would be happy to 2 minutes left. Good. So I can also show you maybe little bit more detail. So you can also, of course, go, you can, for example, click out that. You can say, let's go inside. I want to see a certain part of the city. So I choose, for example, this part of the city, load results. So I see, I have to click a layer so I can see this is 20 gigawatt hours of heat demand and 120,000 square meters. And then I want to check, for example, what might be city test a potential for district heating. This is a very simple module here with just the giving threshold values for minimal heat demand in a hectare and minimal heat demand in the district heating area. Can run the calculation module, and it calculates based on those threshold values the potential for district heating out of the overall potential here. I can also, of course, use my own data. I won't show it now, but you can upload via your own account. You can create an own account and you can upload your own data and use your own heat density maps. You can also use your own. You can change all the layers that you have here. You can change them for your own layers. Good.
Okay. Thank you very much, Marcus, for this quick presentation of the tools. So we'll take some questions. So first question from Marianne, is this linked with the Heat Roadmap Europe project? And if yes, how?
No, it is not linked with the Heat Roadmap Europe project. So it's not the same data.
Okay.
It's data that we generated, mostly based, it's mostly based on open data. So it's the general for the heat demands and also for the floor areas. It's a top-down calculation. So we used the national values for the heat demands and broke them down to the hectare level.
Okay.
The added value
Marcus.
you can use and download the data. That's the added value. For Heat Roadmap Europe, it's possible. You can just have a look at it, but you can also not make a selection and say, okay, I want to see it only for that. Any paper, you mean any journal paper? Still not. It's we just in the final phase of generating the data. We are currently preparing a journal paper on the methodology to generate the default data set. And of course, it's a good question where it will be used in the journal paper. I don't actually know. The intention with the default data set, maybe to tell you that, was to have for each location the opportunity to have a very quick and first estimate. How did you acquire?
Marcus, there is another question from Ashve. How did you acquire your volume of buildings?
The volume of buildings is, it's gross floor area and number of floors and an average floor height. That's it. And the footprint is available for entire Europe. Number of floors is an estimation. we can, I mean, yeah, you have the overall gross floor area, or we estimate the overall gross floor area of a location mainly due to mainly based on the population and on the value added for the service sector, and then of course it has to match with the footprint that is available. Yeah, that's more or less the overall method. The details, yeah, I would refer to the paper. Energy performance, I mean, it's...
Okay, we will take a last question, because then after that we will have to move on. So how do you calculate buildings' energy performance? Is it an estimation based on what?
Yeah, of course. I mean, it's, as I said, it's in the end, it's breaking down the overall heat demand values from the energy balances at the national level down to the hectare level. So we don't need to make absolute estimates of the building's performance, but relative estimates. And these relative estimates, for these relative estimates, we use, let's say, differences between the age classes, and we try to analyze the age classes of the buildings according to which locations or which areas, which footprints have been built in which years. Yeah, so it's an estimation.
Okay, thank you very much, Marcus, for this. And if there are additional questions, then we will ask them at the end. Now I will give the floor to Ashve Dorotic. Sorry, can you share your screen, please? So Ashve works as a project associate in the energy planning group of University of Zagreb's Faculty of Mechanical Engineering and Naval Architecture. Here it deals with technical and legislative issues of renewable energy sources integration and energy system analysis. Its PhD thesis focuses on the development of a multi-objective optimization method for evaluation of district heating systems with regards to individual solutions. So the floor is yours.
Thank you, Julian. Well, first of all, can you hear me?
Yeah, we can hear you. Thanks.
Okay, great. So thank you for a short introduction. I will get strictly to the point. Hello, my name is Ashve Dorotic, and today I will show you the plant heat tool. The plant heat tool will be a result of the plant heat project, and it currently runs until September 2019. That means that we will have to wrap up the whole project in a couple of months. The tool is currently under development, so I will currently just present you the presentation, but you will see later on you will be able to download it and try it yourself by using our guidance. So long story short, the plant heat tool is actually developed in the plant heat project, and it has, let's say, 3 steps. So the first step is to map demand and potential supply. Then you have to create your plan, that is your scenario for heating and cooling. Then after that, you will be able to simulate the results. This is actually, in those 3 steps, is actually those 3 steps are actually covering the 3 modules of the plant heat tool. So in the first module, you will actually map your heating and cooling demand and your supply. Then you will do drafting of your scenarios, and then finally you will be able to simulate them. The most important part is that the tool is open source. It will be user friendly, hopefully, and it is downloadable. So it is not web server, but is downloadable, but all the data which are used are actually stored in the plant heat web server. So let's move directly into the plant heat tool. So when you open the plant heat tool, first of all, you will have to map your demand. And for the mapping demand, we actually have two approaches. One is called city approach, and one is called district approach. And how does it look like? So it all depends on the availability of your data. So if you have just, for example, final energy consumption of your city, then you can use city mapping approach, where your final result will be annual, and your spatial resolution of your heating and cooling demand will be not on the building level, but on some level which will be defined. But if you have the data on the building level, that is, your input data are actual building properties, then you can actually use district mapping module, and then your results will be on hourly level for the whole year, but the spatial resolution will be much higher level of detail, that is, it will be on the building level. So on the city mapping module, we are actually using something which is called top-down approach. So it's a top-down approach where we are actually using the spatial indicators in order to redistribute the heating and cooling demand. So for heating demand, we have actually separated space heating and domestic hot water demand for residential and for services. And also we have residential and service for cooling demand. And according to spatial indicators, so you can actually redistribute your heating and cooling demand according to floor area or population density or any other spatial indicator that you would like. So actually, when you are doing top-down approach, your final result will look something like this. So you will have squares, 50 times 50 or up to 1 kilometer times 1 kilometer. And for each of those squares, you will know what is your heating, cooling, and domestic hot water demand. But also, you will be able to zoom in into one of the regions, and you will be able to check some kind of a report, which will then be able to use later on. So that is the city demand mapping module. We also have a bottom-up approach. For the bottom-up approach, we actually have, so this is the district mapping module. In this approach, we have two types of assessment. One is simplified assessment, where we actually need to have just a footprint area of the building and total height of the building. But if you have additional data, then you could use something which is called complete assessment. And for that, you would also need building use and the year of construction. And as I told you, for the district demand mapping module, we are actually looking the data on the building level. So you will be able to see what is your demand on the building levels. That is, for all of these buildings, for all of these areas, you will know what is the peak demand, what is overall demand, and you will know hourly demand for each building. So that was demand mapping. I will now skip to supply mapping. So for supply, we have different versions of sources. So conventional sources coming from solar and biomass, industrial excess heat, and unconventional sources. And for each of these sources, we have developed a method in order to how to calculate potential supply. So just take, for example, a mapping of the biomass. So first of all, we are using currently available databases on the European level. And first of all, you have to define what is the buffer area around your city. Then we upload the database, which is currently available on the European level. For example, that is forestry for the European Union. And for that, we can calculate the potential of that forestry for heating, which could be used, the biomass, which could be used for heating, and we can also visualize that potential on the map. So for each of those sources, we are actually doing the same thing, but it is just for the biomass. Probably the interesting thing is industrial excess heat. So for that, we are again using different kind of available databases. The one which is probably used most often is ETS databases, which actually just says what is the CO2 emissions and type of the source. So for example, if that is wastewater or is it some kind of facility, then according to the CO2 emissions, we can calculate what is the potential for waste heat. If not that, then you can use your own values. So stepping from the mapping, then we have a planning module, and now this is where actually it gets tricky, because our tool cannot do the optimal scenario for you. That is, you will have to develop it for yourself, but we will guide you in the process. So how do we do that? We actually can define 4 planning criteria. So economic, environmental, energy, and social planning criteria. So for example, for economic is probably most often used creation of economical and feasible scenarios. For environmental, it could be emission reduction, or for energy planning, it could be increased share of renewable energy sources. Then for each of those planning criteria, we have developed several KPIs which are used in order to compare the scenarios between themselves. And now this is where the planning comes in. We will actually, when you define your planning criteria, we will suggest which sources and which technologies should be used in order to achieve that planning criteria. And then if that planning criteria isn't satisfied, we will do again scenario development according to the new set of guidelines that we will give it to you. In the planning module, there is also DHC route optimizer. So this is something, this is really cool because it can show you the best routes, the best routes for your district heating and cooling. But besides the route, it can also show you the diameter of the pipes. So for example, we have 2 approaches. The first approach is actually called automatic building selection, where you can actually say, okay, I want to have, of my district, I want to have 40% covered by district heating. Then you click run, and it actually shows you, visualizes the route for you, and it defines the diameter of each pipe. So for example, we said here that we want to have 30% of our heating demand covered by district heating, and the blue buildings are actually covered by district heating, and you can see the red lines are actually showing the routes, and each of those lines have a different width. That is, they have different diameter. You can also do this manually. Just say, okay, I want to have connected these 5 buildings, these 5 blue buildings, and the tool, it will connect it to you in the most economical and feasible way. And now we are currently working on the rest of the planning module. So how it actually look like? So it will download all the data coming from the mapping module, and for all of the buildings you will have total heating demand and peak demand, and according to that you will define which technologies will be used on the building level. Then all of this information will finally come to the simulation module. The simulation module is actually running the hour-by-hour simulation for the whole year. So actually it is minimizing the total running costs, so fuel costs, operation, maintenance, and so on. And those results are used for KPI calculation. The thing is that the end user has little to no interaction with the simulation module. It only has to press run, and we give the results for them. So for example, we have run a really simple simulation over here, where we define some cogeneration units, heat pumps, and heat-only boiler units. And then you click run, then you will have a picture which looks something like this, where you can actually see optimal operation of your supply capacity on hourly level for a whole year. Besides that, you have thermal storage operation, seasonal thermal storage, and so on. And this is something which is called the load distribution curve, where you will be able to see how many hours have your operation operated on a specific capacity. I will skip this, and then when it will be done, you will finally have a KPI panel where you will be able to check all the key performance indicators on economic, environmental, energetic, and social parameters. And now, how can you try the plant heat tool prototype? Well, first of all, you come in contact with us by sending us the email, or you can check the website. Then you will sign the NDA. The project coordinator will countersign it, and then we will send you the installation package. Then you will be able to install it. Then after that, you will be able to learn how to use the tool. There are several types of how you can do that. So first of all, you can attend training sessions, then you can sign into e-learning platform, and then you will be able to check training materials and training modules, and you will be able to get in contact with us if something is not clear enough. Thank you for your attention. I hope that I was in time, and if you have any questions, I'm ready to answer them.
Thank you very much. Yes, you were almost on time. It's fine. So, is there any question regarding the Planet tool? I think there will be some. A lot of people are typing. Maybe one question is which cities have tested this tool already?
Yes, so in the project we have so-called 3 validation cities. So that is Antwerpen from Belgium, Lecce from Italy, and Velika Gorica from Croatia. And for each of those 3 cities, we will draft heating and cooling scenarios by using the plant heat tool.
Okay. There are 2 questions. One question is everything open source? And the other one, I don't really. Which permit are you speaking about?
Well, first of all, the tool is open source, which means that we are using open source programming languages, and we are using open source a platform called QGIS. So the screenshots that you have seen is actually from the QGIS. It is open source and free to use tool, and we are actually integrating all of our codes in QGIS. The permit is for how long? Well, actually the tool is free, and after the project ends, you will be able to download it and use it for long as you want. And the most important thing is that besides the tool itself, we are also creating a plant heat web server, which should be done in a couple of weeks, and you will also be able to connect to it. So this is this part over here. So we are actually drafting all our data and storing it in the plant heat web server, and you will be able to use all, let's say, the default values which will be ready for you. So yes, everything is open source.
Maybe we will take a last question. Is the trial available to commercial users?
Not sure what you are speaking of. So the tool will be free. The trial is available. So as you can see here on this slide, so you just have to come in contact with me or on this official email, and you have to sign the NDA, because the tool will be officially available after the project ends, but you will be able to get a prototype version and you will be able to try it out. So it is ready right now, but you just have to this procedure to get over, and you can have a first look at it. Or you can check the training sessions which are available on the Plant Heat website on the training session event. We are currently preparing sets of live and webinar sessions for the Plant Heat tool.
Okay, thank you very much. I think we will move forward to the last tool.
Thank you.
So the thermos tool. Thank you very much for your intervention. Martin, can you share your screen, please? Thank you very much. So Martin Hawley is a senior technical project manager at the Center for Sustainable Energy in Bristol, where his role involves managing a wide-ranging portfolio of projects for private and public sector. It concerns all aspects of sustainable energy supply and use, and is working in the team at CSC who coordinate the H2020 Thermos project. The floor is yours, Martin.
Okay, thank you very much. Hopefully everyone can hear me.
Yes, we can hear you.
Good. So yeah, so my presentation is going to be mostly just demonstrating the tool, but I've got the Thermos website up here just to, for reference. It has all the information about the project and the partners we're working with and the cities that we're testing the tool on, and also how to get involved. So when you get a chance, have a look at the website there, and you should have all the information on there that you might want to read about. Our project finishes in June next year, so we are still in the development stage of the tool. But what I wanted to demonstrate today was the latest version of the tool, which I've skipped an initial step here, but just to go into the first bit where we need to create a map, really, because this is an open source software application which is designed to help in the early stage planning of heat networks. It's accessed through a web browser, and once you've logged in and set up a project name, the first thing to do is to load up a map of the area that you're interested in, because we're actually going to build our own map here. And so I'll just demonstrate this quickly. So we're just going to give it a name to start with, and if we wish, we can give the map a description. And then what comes up here is a map which, in this case, it defaults to London, because this is where my map will be based, and it shows buildings and road geometry from OpenStreetMap. We can, in fact, search for anywhere which is covered by OpenStreetMap to locate our area of interest. And we will be taking data, in this case, from OpenStreetMap, but we also have an option of uploading our own GIS files, if you wish, which could contain information such as actual heat demands of buildings and things like benchmarks, etc. So there's that facility, but just for this demo, I'm going to be using OpenStreetMap data. So we can either search for a particular area of interest or actually select an area. So what I'm going to do is zoom in a little bit here and use a drawing tool to select, say, this particular area. If I click next, and we also have the option for road geometry to upload your own GIS files as well. But again, we're just going to use OpenStreetMap data for this. And the final thing to do in creating our base map is just to enter some initial parameters relating to heat demand and cost, network cost estimates, which are used in the modeling. So heating degree days, the default connection cost, and pipe costs there. We're now ready to create our map. So what's actually happening now is the tool is querying the OpenStreetMap data site for the data, and it's run a series of calculations to estimate heat demands. And you can see there you've got a map icon there which represents the area I've just looked at, just selected. It shows that the map is ready, it's been processed. And the next stage is to view the map, where we can actually start building our network. So this is the main interface of the tool, where I can start selecting buildings and constructing my network. What you can see there is just a satellite image of London, but if we start zooming in, you can start to see the area that I've selected highlighted there. And this is showing building polygons and the line routes that were within the area that we've just selected. And so these have just been all imported from OpenStreetMap. And we can then start to construct our network within this. If I zoom up a little bit more, you can see that as well as buildings, the network here, or potential network, is what we have is a noded set of paths which all join each building, through which we can then start planning our network. And we're able to select individual parts of this network and also buildings, and you can start to view information about the candidates that you've selected. So I say candidates here, which refer to the elements of the network, which are buildings and the connections and the routes as well. So for buildings, you can see there estimates of heat demand, and for the routes, you can see estimates of the length and the base cost of building that pipe along that route. We can also switch map layers on and off using this menu. Just take off the satellite there, for instance. And also we can view a heat map of the area, which then gives us a sort of visual indication of the heat demand hotspots as such. Now, if we wanted to look at options for a heat network in this area, then we can start to select the candidates which we think have potential to be part of the network, and we can use one of these drawing tools to do that. So I'll now try and select an area of interest. I'll just use a polygon drawing tool here. And what we can see there straight away is that all those buildings and the routes have been selected. And over in the right-hand pane, we've got information here about that selection, including the total number of candidates selected, the types and classifications of the paths and buildings. And we've also got a kind of, each of those elements has been given a status, one of three conditions, if you like, and by default, one of those conditions is forbidden. And so that when they're forbidden, it means that they will not be included in the network analysis by the model, and they're all shown in white. But obviously, we want to include some for the model. So what we can do is to start to select candidates and change their status to one of two things. And for now, I'm going to change them to optional. So I'm going to set all the roads and pathways to be optional and do the same for the buildings. And you can see there that they've been outlined in blue. And this actually means that they're optional, which means that the model, once we run the model, will decide whether or not to include them in the network solution, just depending on what the desired outcome is. Or we can also change the status of a candidate to the third status, if you like, which is required. And what I'll do here is pick on one building, and I'm going to set that to required. So that means that this building must be included in the modeled network solution. So all the others at the moment, it's up to the model to decide whether that includes them. But this one must, is something that we would really like to be in the solution. And at this stage, it often helps to remove all the forbidden candidates, which are still in white. So I can do this just by clicking on that one. I'll also get rid of the satellite view, just to make things a bit clearer, and the heat map. So we can see the beginnings of our potential network there a bit clearer. And looking again at the right-hand pane, you can see again that the data here, the demand and the peak estimates. And these have been produced using a fairly sophisticated regression model, which is based on the shape of the building. But as I said, had we uploaded our own GIS data, we could actually potentially have actual demands here, or we could also put in benchmarks, which can vary, you know, from country to country on what's used. So you can put in your own local information there and upload it, and it will be incorporated into the information behind this map. So what we've got here now is a selection of buildings with heat demands and paths connecting them, and that the red candidate must be included in the analysis, but all the rest are optional at the moment. Decide, that's up to the model whether it's included or not. And then the next thing to do is to specify a heat supply location. So we can do this quite easily by selecting a building which it could be suitable for hosting an energy plant, for example, and switching it over to be a supply point. And what you get there is just a prompt to enter some specific parameters for that heat supply plant. And I'm just going to put in a few figures here. You can see there's a list of parameters and some emission factors there, which kind of just gives you a specification, a base specification for your energy plant, supply point. And you can see there that, that you've got some white stripes, which indicate that this is now a supply point. If I switch to the Options tab, you can see there's another set of parameters that we can tweak, which all then are incorporated into the model's financial analysis. And there's some defaults for heat sale price. Just tweak that down a little bit, and then we've got emissions factors and other parameters there which we can experiment with and tweak if we want to. So going back to the map, we can also edit individual buildings. If I click on one and right click, we can also, for each individual building, put in a range of parameters, to override the defaults that the software's assuming. And similarly for the rows and the paths, we can edit the costs of those as well. Is that that's dependent on a number of things, but if you have better estimates than this model, then there's a chance to put those in there. So that's all the basic preparation work we need to do before asking the tool to try optimizing the network scenario we just built. So what I'll do is save this configuration, just give it a name.
Yeah, Martin, I think we will have to move forward for the question.
If I got 1 more minute. Okay.
Yeah, sure.
Okay, I'll give
1 more minute.
I'll rush through this then. So I've just saved that the configuration, and I can now click on Optimize, which is actually now running the model. And how long this takes depends on the complexity and the scale of the problem that you've allowed it. So there, the first thing to notice is that the colors changed, and you can see that the green indicates the candidates which were characterized as optional but subsequently not included in the solution because they were considered suboptimal, and the blue indicates those that were optional but were included in the solution, and of course the red is the one that you needed to be in the solution. And you've got the magenta ones just mean that they were inconsequential for the model because they didn't really go anywhere. And you can look at the information in the right-hand pane there regarding the solution, and also in the results tab you have a summary of the outputs, then the model solution, including one of the most important figures here, which is net present value. And then it's just very easy to go back and you can tweak things and change parameters here and there and run the model again to see what differences it will make, and if you want to optimize on MPV or if you want to look at emissions, that kind of thing, it's very easy to do that. So I'll finish there so that we've got time for any questions.
Okay, thank you very much. So there will be some question, I think. My first question will be about the optimization of existing DHC network. Is it possible to use the tool to do that too?
To optimize what, sorry?
To optimize some existing, because here you are showing us a new, you like to do a new network, but if we already have a network, can we use the tool too?
Yes, you can. It's possible to do that. You can either build it in to start with a map and enter the figures, or you can configure your GIS file to upload the various information that the buildings that are existing there, being provided by an existing network. You can make sure that they're in and they all have the right parameters and demands and the routes, which then will be reflected on the map. So yes, and that's something we will be adding in to a greater extent in the future as well.
Okay, thank you. There is another question about hydrodynamic calculation. Is it included in the tool too, to know, for example, the pressure losses?
It's there's a range of technical inputs and outputs for this. I'm not going to go into too much detail here at the moment. We're working on the methodology that's used behind this, and we're going to bring out a paper. But we draw on a range of information about the networks and the pipe diameters and the hydraulic flows and the powers that flow through those pipes and the assumptions that we make with sizing those pipes and the cost and the terrain that you need to go through in order to lay those pipes. So yeah, and most importantly, we are testing this with professionals in the industry against the conventional ways that they do this already for various clients to see how both methods compare.
Matteo, please, can you tell us, because there is one question from Matteo, does it manage quota? But for who is the question, please? For the thermos.
Okay, what do you actually mean by quotas, Matteo? So Matteo's written the altitude of building locations. So is he referring to the pressure, the hydraulic differences in
yeah, I think so.
Locations? Oh, if you're in a hilly area, for instance, yes. Not at the moment. Yeah, differences in the height levels is something we're looking at as we refine the model and we go forward. So yeah, at the moment I don't believe it does.
James is saying that this may be covered by the degree day input. But I think here we are more speaking about pressure in the network.
I think James is referring to the climate there more. I believe, yeah.
Yeah. Okay, thank you.
Climates.
We had another question before. I think it was for Marcus. About the disaggregation of the national heating demand, and the question was if each hectare attributed the same national value, or are there differences for urban and rural area? I think it's, there are differences because the heating demand, as you have seen in the map, it's not the same in, for example, in the city than in rural area, because it's based on the building characteristic impact. Is it correct, Marcus?
Yes. Yeah, I'm not fully sure about the question, but yes, no, I mean in general we use the national demand, the national values for heat demand for space heating and hot water generation in the buildings, and we break that down to the hectare level, and this is done via knowledge on, I mean, on the NUTS 3 level, on different combination of building types and age classes, and we also use then maps for population density. We use also added value at the LAL2 level, and then we have the building footprints. So this leaves, let's say, heat demand in a certain area, at the LAU area for residential buildings, let's say, and then we define, or we distribute this heat demand according to the footprint, and then we have a total area, gross floor area in the residential sector, for example, that has to be distributed in that footprint, and for that we use a relation between the height of the buildings and the footprint of the buildings, which we have derived out of OpenStreetMap data, and also it depends. We calculate differences based on the heating degree days of a certain location.
Okay, thank you very much. Then maybe my last question will be for Marcus and Martin, because we didn't discuss that, is with which cities are you testing the tool right now, just to finish, and then I think we will conclude.
Maybe I start. We have 7 pilot areas in the project, so, and 6 of them are cities, and 1 of them is a region. It's San Sebastian in Spain, it's Kerry County, it's in Ireland, it's Milton Keynes in UK, in England. Then we have Aalborg in Denmark, we have Frankfurt in Germany, we have Bistrița in Romania, and which one is left?
Geneva, maybe, no?
Geneva, yes, Geneva is left. Geneva in Switzerland.
Okay. And
all of them. Yeah.
Yeah, no, sorry.
Yes, and all of them are testing the tool and the default data, and also the calculation modules, and for 6 of them we also calculate scenarios and develop strategy elements for heating and cooling, let's say, future outlooks.
Okay. Martin, which which cities are you working with?
Okay, so we're working with 4 pilot cities, which is Jelgava in Latvia, Warsaw in Poland, Granollers in Spain, and the borough of Islington in London. So they're the main local authorities that we're working with initially to test the tool, but alongside that we have 3 replication cities as well, who will be then learning the same experiences as the pilots. One of them is Cascais in Portugal, we have Albulia in Romania, and we have the GLA, which is the London, Greater London Authority. So, and it's targeted at you know, local authority officers, planning or energy officers, really to do kind of pre-feasibility studies, then to sort of home in on particular areas which are of interest, which they can then go on and do a detailed sort of technical feasibility study on.
Yeah, thank you very much. Yeah, I think it's the main advantages of these 3 tools is that it allows to do some pre-feasibility studies for cities, which avoid them to use, I mean, to spend a lot of money on pre-feasibility studies with consultancy company maybe, and go directly where they want to do feasibility study after using the tool. Thank you very much to all of you, the four of you, because it was quite a short time for each of you, but you manage it. Thank you for all speakers, all people involved in the organization of this webinar. The recording of this webinar will be available on the Celsius website and probably on the different website of the different projects. And yeah, we thank you for joining us today, and see you soon. You have all the contact here on this slide if you want to contact the different projects and start to work on your heating and planning process. Thank you very much. Goodbye.
Thank you. Bye-bye, everybody.